Good morning and welcome to this course, Physics 1. This course is generally made for undergraduate level BTech degree students. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baraipur. You can contact me personally at college premises, ground floor, physics lab. You can also send me your query and your doubt at my email address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jsgroup.org. I have a YouTube channel. You can visit my channel and subscribe my YouTube channel for lots of video regarding this physics chapter. The corresponding course pages are www.macoutexam.net and www.macoutwb.ac.in. You can also find the syllabus is uploaded in that page in Macout website. The title of the course is Physics 1. The subject code is BSPH101. It is under the category of Basic Science course as credit 4, and it has 3 lectures per week and 1 tutorial per week. The course is generally made for undergraduate level BTech students and especially for first year BTech students. So, for odd semester, computer science, civil, mechanical, these departments are going to study this course, and alternatively for the even semester, electrical and electronics and communication, these departmental students will going to study this physics course. Today I am going to discuss especially the periodic motion, simple harmonic oscillator, its energy and its application. So, this first part is under Module 1, Mechanics. The prerequisites are fundamental of mathematics and elementary idea of physics. The course objectives are: compare the observed motion of the system to a mathematical model of an object in simple harmonic motion. Learn about position, velocity as a function of time and energy conservation law for a particle executing simple harmonic motion. So, after completion of this course, the course outcomes will be able to measure the position and velocity as a function of time for any system executing simple harmonic motion, determine the amplitude, period and phase constant of the object in simple harmonic motion, examine the energies involved in simple harmonic motion, test the principle of conservation of energy. So, these are the possible course outcome. Now, as per your syllabus, you have only damped harmonic motion and forced harmonic motion in your syllabus, which is actually the extended part of simple harmonic motion, because in case of simple harmonic motion, some consideration is there which avoids all the frictional force or damping force or resistive force associated with that system. So, we actually exclude all this kind of a force. So, after that, when this force comes into act, damping force or frictional force, then this type of simple harmonic motion is converted to damped vibration or damped harmonic motion. Again, if some periodic force is applied to oppose the motion of damped vibration, then that kind of motion will be treated as forced motion, or forced vibration. So basically, without knowing simple harmonic motion, it will be very difficult for you to understand what is damped vibration and forced vibration, and it will be also difficult for you to derive or to calculate the differential equation of motion for damped as well as for forced vibration and corresponding solution of this motion, because without knowing any value or expression of displacement, which is x or s, so you can't give the answer that if someone asks you what will be the position or displacement of particle after a particular interval of time, without knowing any expression, it is not possible for you to give the correct answer. So that's why you need to first construct some differential equation of motion, then you have to solve this differential equation of motion putting some boundary condition. Okay, so one by one you will get the complete solution of this equation of motion. So first of all, the very basics or preliminary idea that you needed is the concept of simple harmonic motion or simple harmonic vibration. So this is the very basic to know that makes damped or forced vibration in very clearly. So first you try to understand what is simple harmonic motion. In this video I will explain in details. Okay, in next two video I will discuss about the damped vibration or forced vibration. So motion is basically a phenomena where the object changes its position with respect to time, and mathematically it can be described in terms of displacement or distance, velocity, speed, acceleration, etc. Many types of motions are there. So here you have to concentrate over only the periodic motion. Okay, so periodic motion means where the particle or object repeats its motion along a certain path about a fixed point after a certain interval of time. So in case of periodic motion, the particle must cross a certain point, fixed point, within a particular interval of time. So this kind of motion is called periodic motion. That means it has a periodicity in nature. Okay, so lots of examples are there. A very common example is a clock. Okay, so in case of clock, the motion of minutes hand or the second hands or the hour hands, these hands cross a particular point after a certain interval of time. So motion of this minutes hand or hours hand can be considered as a periodic motion. Okay, or motion of a pendulum. Motion of a pendulum, the pendulum is oscillating from midpoint to left and again midpoint to right. So again after a certain interval of time it crosses the fixed point, particular fixed point. This is another example of periodic motion. Or motion of earth around the sun, this is also a kind of periodic motion. Or motion of a vibrating spring. Okay, if a spring is and a mass is hanging with that spring, okay, you just raise that mass, raise the spring, okay, and you just release. So that motion of that spring is treated as periodic motion. So lots of examples are there where you remember that where it repeats its path after a certain interval of time, it will be called periodic motion. Now came to the point, what is simple harmonic motion. So this is very important for you to understand in details what is simple harmonic motion. So oscillation where the retarding force or restoring force comes into act. Okay, so due to that application of this force, which is called as retarding force or restoring force, that amount of displacement from mean position of rest or equilibrium position is directly proportional to it. Okay, so that means oscillatory motion under a retarding force proportional to the amount of displacement from equilibrium position. This is called simple harmonic motion. Now the simplest example is that simple pendulum and mass spring system. Okay, now you have to understand how simple harmonic motions compete a circulatory motion or periodic motion, or why its motion is considered as sinusoidal, or it can be represented as sine graph or cosine graph. Okay,
you can see the diagram is given here. Okay, when the particle is at rest, the particle is at point A before starting the motion. Okay, after starting the motion, when it comes to point B, you can see here, so that means it covered at angle or phase 90 degree, so moves the position from A to B. So it now acquired a maximum amplitude. Then again it covered a phase of 180 degree, so it goes to point C. Okay, then again it comes to point D and ultimately E. So here A and E are the same point. You can say it's a starting point or ending point. So these 2 points are same. That means this is a fixed point around which the particles is executing its simple harmonic motion. So after completion of this motion, if we plot this graph amplitude with time, we got a sine curve. Here it is denoted by A, B, C, D, E, and it also complete a circle. That means simple harmonic motion is a special type of periodic motion where the particle repeats its path after a certain interval of time, and that force, restoring force or retarding force, is directly proportional to the displacement from its mean position of rest. Now we are going to construct the differential equation for simple harmonic motion, and then we solve this equation to get the expression of displacement x. So as I have told you that here a restoring force or retarding force comes into act, which is directly proportional to the displacement from mean position of rest. So that force F can be written as F is proportional to minus of x. Okay, so minus sign is because the direction of that force, the retarding force or restoring force, is proportional to the displacement, but it acts in a opposite direction. Okay, that's why it is called restoring force, because it helps to restore the original position or position at before time where the particles are at rest. Okay, or at particular fixed point after a certain interval of time. So that force is proportional to minus of x. Now as per Newton's second law, you know that force means mass into acceleration. So m d2x dt2, that is equals to some proportionality constant must be there. So here I have considered k is the proportionality constant, so equals to minus k of x. Now k is called restoring force constant. Restoring force constant is defined as force per unit displacement. Okay, so this is the equation. So if you rearrange, you will get m d2x dt2 plus kx equals to 0. Okay, dividing both sides by m, you get d2x dt2 plus x by m into k is equals to 0, where m is the mass of the object or mass of the particle and k is the restoring force constant. So now we consider omega square, that is equals to k by m, where omega square is the natural frequency of oscillation, angular frequency of oscillation. So omega is equals to under root k by m. So substituting that value of omega, we will get our differential equation for simple harmonic motion. So that is d2x dt2 plus omega square x equals to 0. Okay. Now the solution of this differential equation is x equals to a sine omega t plus theta, where theta is the phase. And if you know that omega square, that is the angular frequency square, equals to k by m, so from there you can easily find out what is the natural frequency of oscillation, because omega equals to 2 pi by t, where capital T is the time period of oscillation, or 2 pi nu, where nu is the natural frequency of oscillation. So nu can be written as omega by 2 pi. So from there, using this equation, you can easily find out what is the displacement of a particle executing simple harmonic motion, what is the natural frequency of that particle, and also what is the corresponding time period.
Now, after knowing the expression of displacement x, it will be very easier for you to calculate the velocity of that particle executing simple harmonic motion and also the acceleration of that particle, because you know the velocity is written as rate of change of displacement. So v equals to dx dt and a equals to dv dt. As x equals to a sine omega t plus theta, so velocity v will be a omega cos of omega t plus theta. So from the first equation, you can write x by a is sine omega t plus theta. So as we know, sine square theta plus cos square theta equals to 1. So cos theta will be under root 1 minus sine square theta. So from there, you can substitute the value of cos omega t plus theta, which will give you v equals to a omega under root 1 minus x square by a square, that is equals to omega under root a square minus x square. So this is the expression of velocity. Now acceleration is dv dt, rate of change of velocity. So that is minus a omega square sine of omega t plus theta. Now you see, if you substitute the value of x in terms of acceleration, so you will get acceleration equals to minus of omega square x. So that means acceleration is proportional to minus of x. So which is actually, we comes back to the definition from where we have started, that is force is proportional to minus of x. So here in that equation where acceleration is proportional to minus x, so if you multiply both sides by the mass, which is actually a constant, which doesn't going to change any value, so this proves that simple pendulum is executing simple harmonic motion. Now, as per our diagram, if we consider two boundary conditions, one is the mean position of rays, that means where x equals to 0, you substitute the value in expression of velocity and expression of a. So what you will get, at x equals to 0, your acceleration is 0, but velocity is maximum, that is a omega. And alternatively, at the end point, that means where the particles are achieved maximum amplitude, so at x equals to a, you will get the acceleration value is maximum, that is minus of omega square a, and the velocity is 0. So Putting this boundary condition, we can say that the velocity of the particle, or here the pendulum, will be maximum where the acceleration is 0, so at mean position of rest, and at the far end point you will get velocity is 0 and acceleration is maximum. So we can say at the mean position of rest the particle achieve maximum kinetic energy, because the velocity will be maximum at that point. As we know, the kinetic energy expression is half mv square. So as v is maximum, you will get the maximum kinetic energy at mean position of rest, and minimum kinetic energy 0 at the far end position. As I have already discussed that at mean position of rest you will get maximum of kinetic energy, and at far end, that means at maximum amplitude where x is equals to a or minus a for both sides, you will get your potential energy will be maximum, because your kinetic energy is 0. As we know, as per energy conservation law, it always states energy neither be created nor be destroyed. So total energy of the particle is always constant. So we are going to prove this energy conservation law, okay, to finding out the calculating the value of kinetic energy and potential energy. Then total energy will be the sum of kinetic energy and potential energy. So as we know, the kinetic energy is half mv square, so we substitute the value of v and we will get half m a square omega square cos square of omega t plus theta. Then in case of potential energy, so potential energy, basically work done by to change that position is actually converted or stored as a potential energy within that simple pendulum or the particle which execute simple harmonic motion. So as we know, the work done is f dot dr or dx. So integration over that will give you the total work done, which will totally converted into potential energy. So here I have substituted the value of f, that is f equals to minus of kx. So okay, and then taking the integration, that is give you half kx square. Now as we substitute omega square equals to k by m, so from there we can substitute the value of k in that expression of potential energy, and you will find the potential energy is half m a square omega square sine square of omega t plus theta. Okay, so now you just sum up your kinetic energy and potential energy. You can find out that your sine square theta plus cos square theta will be 1. So you can take common your half m a square omega square. Each term of this equation is a constant, because m is the mass of the particle, a is the maximum amplitude of oscillation, which is also a constant, and omega is the natural angular frequency of oscillation. So all these are constant. So we prove our total kinetic energy and potential energy, that means total energy of the system is conserved. If you plot the graph between energy with displacement, I have shown you here, the blue colored graph is considered as a kinetic energy, and the dotted red one will represent the potential energy graph. So this graph is very important for your exam purpose. We have completed the theory part, theoretical concept. Hope you understand. Now we are going to solve some example. So first one, the first example is the most simplest one. A simple pendulum is an idealized mechanical model comprising of a point mass suspended by a mass less an inextensible string. So when a pendulum is pulled to one side and released, it oscillates about its equilibrium position in simple harmonic motion. So you are going to find out what is the frequency of oscillation or time period of oscillation. So first of all, you have to show that simple harmonic motion is executing here. To solve this kind of problem, first you have to understand the diagram first. Okay, the mass of the bob, that is m, okay, and the corresponding weight of the bob will always act in a downward direction, that is mg, which has two components. One is mg cos theta and mg sin theta. So mg cos theta will be cancelled out with the tension of the string. So mg sin theta is basically act as a restoring force for which the particle executing simple harmonic motion. So you can equate the mg sin theta value with our retarding force or restoring force. Here the L is the length of the string and theta is the angle, which is very less. So for simple harmonic motion, it must be less than 4 degree. So as I have discussed, you can write F is equals to minus of mg sin theta. So as theta value is very less, so we can write sin theta will be equals to theta. So F equals to minus of mg theta. So where the sin theta value is, or theta value is x by L, we substitute that value. Okay, so we get our omega is equals to k under root k by m, where k value is mg by L. So will be cancelled out and you will get your angular frequency omega is equals to under root g by L. So your time period of oscillation as omega equals to 2 pi by t. So your t or time period will be equals to 2 pi root over L by g. So these are the other problems you can practice. First one is calculate the time period of liquid column of height L in a U-tube. If it is displaced in one arm by x, rho is the density of the liquid and A is the cross-sectional area of each arm of U-tube. I have already solved this problem in my another video you can find in YouTube. Okay, so question number 2, 3, 4 also are important question. You can practice in home, or I have already solved these problems in another video that is already uploaded in my YouTube site. You can visit and check there. Now these are the important books that you can refer or consult. Evaluation process are same. Your internal will be for 30 marks and your external will be for 70 marks, out of which for under the internal examination will be held for 15 marks, 10 marks for assignment or quiz and 5 marks for attendance. So these are the marks distribution for your evaluation for this subject physics 1. Hope all of you have understand the very basics of simple harmonic motion, because this video or this class is very important for you for your next 2 class, because where you are going to study damp vibration and force vibration. So with taking the knowledge of simple harmonic motion, that will certainly help you to understand those chapters in very easily. Okay, so hope you all enjoyed this class and this chapter. If you have any problem, you can mail me at my given email address. Thank you.